Mentor Hour by Knit 6. This week we have Quinn Snyder. Wait a minute. Sorry. The mighty Quinn Snyder will be going over the benefits of NSO. So please join us. We got a little long-winded, but I don't stop greatness. I let it pour. So there's a lot of information here. Please review it and give me your thoughts and comments. Talk to you later.
Do you understand?
Of NSO, and that was like my first automation love, even back in the 2.x days, 2015, 2016. So tried to bring my customers on board with automation and NSO and just all the things that you can bring when talking at scale. So, but most of my time now is spent in DC networking. I kind of cover that area for DevNet, so ACI, NXOS, all the things that come with that, and integrations with open source products like Ansible, Terraform, and things along that. So if I'm not coding, you'll generally find me out. In fact, today I've got an 8-pound pork butt sitting on the smoker that's going to be dinner later tonight. So if you follow me on social, get ready for a mix of tech and low and slow cooked meats, if that's your thing. I will go ahead and share. So I've got a couple of things. I want to do a quick presentation, just kind of level set on what NSO really is and what it does. There's a lot of, I don't want to say misconceptions, but maybe misunderstandings of what NSO really brings to the table, why it's powerful, but some of the things you have to look out for because it is so powerful. So I want to kind of do a level set of why NSO was created, what it does, how it goes about its thing, and then we'll walk through some live demos using the NSO sandbox within the DevNet sandbox ecosystem. So if at any point in time I speak too fast or don't make things clear, tell me to shut up and restate something, ask your questions. Feel free to interrupt, please, because there's a lot of stuff here, and I've tried to distill it into the most important. You won't be an NSO expert at the end of this, but if I gloss over things a little bit too quickly, please tell me to slow down, and I'll figure this all out. So hopefully you can all see my screen. So this is all about NSO, impressing your friends by learning XPath and Yang and all those other things. At QSnyder, you can find me. Usually GitHub or Twitter are my most commonly used social media platforms, but you can find me anywhere smoked meats are cooked. So getting into the presentation here, gone over all this. Here's all my social contact information. I usually try to keep things mostly tech and or food related, but I can go off on random tangents. So let's start off with the problem. Why are we even looking at NSO? And for those of you who have looked at any amount of automation, this is just something where we're writing some NetMiko type handlers where we're connecting to a device and seeing if BGP is configured, and we're doing it across a variety of different platforms. You see iOS XR, and Arista's VOS. It's a lot of code to see if BGP is configured on a device. And for those of you who are not Python savvy, this can be intimidating. And for something as simple as we want to see if BGP is configured, that's a heavy lift for people who aren't ready to take that plunge into network automation programmability. But there has to be an easier way, and lucky for us, there is. And unfortunately, you can't just go to your vendor and say, give me 4 automations because I want to use them in one of each of my data centers. But Cisco has NSO, which is kind of close. Overall, in terms of the presentation, I'm going to try to stick to this structure. So we're going to talk about structured data and Yang models and what they mean, and then how they apply to NSO and how it does what it does. We'll get into some nitty-gritty about NSO architecture and what makes it unique in the network automation space, mostly because there's some really cool things that I didn't understand the power of until I actually got under the covers of NSO and started realizing how all these things are interrelated. So it may seem a little heavy in those portions, but I'll try to break it down to make it at least relevant and seem a little bit more real. We'll get into NSO operations and some service development to show how to build simple services, which is kind of the bread and butter of what NSO does. And then we'll go through and demo some of the things I've talked about, like I said, using the NSO sandbox.
So guys, just so you know, structured and data and Yang models. These are going to be something that you're going to be explaining to junior engineers in the future, right? So just keep an eye on this and listen. And hopefully, do we get a copy of the deck afterwards? Is this published or no?
I could make a PDF because there's some source files that are going to come with some of this as well that might make it handy to bootstrap. And I've been meaning to create a GitHub repository of them, so I could take a PDF of this. And it's just half of this is just random ramblings out of my own head. So there's nothing like crazy proprietary about this, and the other half is just stuff I've pulled off of other NSO decks. So I can make a PDF and have this published.
No worries. All right. So this guys, this pay close attention. Take notes. Thanks, Quinn.
Yeah, no problem. So we talk about structured data and unstructured data. So this is really the fundamental challenge that we have as network automation engineers, network programmability experts, or things where even we just want to take two systems and glue them together with some APIs. We need to have structured data, and we need to have the right structured data. So when I say structured data, I'm really just meaning that we have some kind of normalized breakdown or parsing of data that we can search either through like key value pairs. If we're looking at JSON, we can look through XML tags, something where it takes the data and puts it into a predictable structure so that I can query this long list of data using standard programmatic constructs. If I'm doing something in Python or Java or whatever else, I can find those key and values or those tags and extract that data and present it in a form that I find usable to me for my use case or my business case. That's structured data. Unstructured data is everything else. So if it's not structured, it must be unstructured. So if we take a standard look at an iOS configuration, this is actually running from a NetSim device, the old school NetSim devices that were coupled with NSO. This is a standard iOS config that we're all used to seeing. We're used to it, but we shouldn't have to like it. We are used to understanding what all these things and commands mean, whether we're talking about, policy and class maps for QoS, we're talking about IP addresses on interfaces, whether we're talking about BGP configuration. We know how to look for those things, and we can parse them and make heads or tails of them because we've trained ourselves to do that. But in terms of having a machine do that, it's very difficult to do because these things could move around. Even if we move, the example that I always bit me was working on Nexus 7000s in the early days, 4.2 and 5.0 code. Every time that you upgraded the code release, the description on something like an SVI interface would move from the top to the bottom. Sometimes it would be in the middle. So it was very difficult, if I'm trying to figure something out at 3 a.m, which SVI is this? And I'm trying to parse through and figure out based on descriptions, it's kind of hard to see that. And we've trained ourselves to say, well, if it's not here, it must be somewhere else. But we can't just do that pattern matching in a machine without having a lot of complex regular expressions to find that. So we're used to it. We've trained ourselves to get along with it, but we don't have to like it. The other thing that you hear a lot of within Cisco now is this intent-based networking, and I won't get into all the details behind it, but really what IBN is supposed to be is we take business logic or business operational process, something that we need that's driven by what makes us money, and we translate that through various levels of interpreters, configuration parameter parsers, and things like that to create some kind of network infrastructure. At the end of the day, the network infrastructure is still programmed and configured using the same CLI configs or through APIs that are translated to CLI configs that we would normally do by hand, but this allows us to have a closed loop of feedback. So we have this business intent, we translate it and apply it to the device, we gain some assurance out of that, whether that's configuration assurance or whether that is end state assurance through is the network performing the way it needs to be. And then if things need to change or differ or we have new business logic that needs to be implanted in that, we can apply that back and have this constantly looped feedback through our network infrastructure. But don't let the glamour of this IBN thing really mean that the network is configured any differently. We may be using different tools, maybe using orchestration, maybe using APIs, higher level constructs like Terraform and Ansible, something like NSO, but we still have to apply that configuration to the infrastructure and provide a way to have that contextual aware programmability to make sure that we are getting what we need to at the end of our journey. So IBN requires context and assurance. So in order for us to get context and assurance, we have to look at look at something in terms of more of a gestalt type approach. Normally, if we talk about device-centric automation, if we're using something like Ansible, we have to apply our intent through our individual playbooks, or if we're doing it through even through standard CLI, we have to say iOS 1, iOS 2, iOS 3, and iOS 4. We have to build those configs, apply them to devices, and then make sure that everything is running. I can't tell you how many times I've been consoled into a device and tried to dump a bunch of text, and suddenly it barfs on itself midway through, and then I'm going to go back and figure, oh, what was applied, what worked, what didn't. Sometimes I may be making differential changes to access lists or BGP neighbor statements, and I always forget, is the syntax, do I have to remove the BGP neighbor, then change it, then reapply, or can I change on the fly? The other example is like that VLAN switchport trunk allowed VLAN. If you miss that add, you're going to wake somebody up at 3 a.m. We have to know how those configs are going to be applied and make sure they're working at the end of the day, but we have to be that intelligent engine driving that change. If we look at more of a service-centric automation, which is really what NSO focuses on, is we have this idea where we have configuration assurance because we know a priori, we know before we do this, is the configuration going to be applied and in the correct order, and making sure that all those dependencies are met ahead of time. So we've automated the assurance of our configuration by saying, are we going to apply? And if we can't apply everything in the correct order, we're going to roll it back and make sure that we don't have any hanging cruft of config. So when we make a change to the network, everything will be applied in that correct order to ensure that our devices are going to be functioning correctly. And I love this quote up in the end, up in the corner there: to assure what's orchestrated, we must orchestrate assurance. And that's one of the fundamental tenets of NSO, is that we are orchestrating that assurance through our engines, through what is driving the configuration towards the device, to make sure that when that configuration is applied, it will work. And that's through a bunch of things into the hood, fast map services and things like that. But if I write a config and it says we're going to take it, and I apply it to the device, that config will be applied at the device level at the end of the day. So if we go back to the other piece of it, so we've talked about the assurance, but now how do we get context out of these configurations? So without those data structures, we are left in a world without context. So this is just a standard targeted show running config from a Cisco device. And this is the NetSim device, but it could be any other Cisco device out there. So we've run this targeted show command. We don't know, are those no commands, are they default, or were they manually set as part of that configuration based on that iOS version, major version, minor version, release, bug fix, whatever else? Are those commands by default? We don't know. I'm assuming that things without the indent are in the main config hierarchy, but I've seen instances where Cisco iOS has pulled out and removed some of those indents in the configuration. So I'm guessing it's just if I do conf t and put in IP source route, it's going to be there. But it may not. I have no idea of knowing that ahead of time. I also know that those IP addresses exist on that device, but where? I would have to go through some regex matching, maybe look through, do some targeted show, or maybe do before or after for some interfaces. I may have to run another show command, maybe show IP int brief and say, oh yeah, this IP address sits here on this interface, but it's a multi-step process. I don't know where those IPs exist, even though I should be able to just by looking at that config, because I'm looking at IP-centric information. And this brings us to the final challenge of really network programmability when we're talking about a non-API centric model. So in order for us to program the network, we have to have some kind of API that we can work with and interrogate that provides us that context and a way that we can ensure that assurance in the network from our configuration standpoint. So network programmability is drastically slowed by having CLI-only infrastructure. 10, 12 years ago, back in the olden days, I was working on things with expect scripts, and we could wrap that in a PHP front end. But at the end of the day, it wasn't really API driven. I was just using a hack to try and send some commands towards a device. We didn't have that way to work with the device. And more importantly, we didn't have a network controller that could provide that API gateway functionality. So I was still doing a device by device orchestration using expect, and was hoping that something didn't break along the way. And I had no way of rolling back. If something was only partial, I'd have to sort through and figure out, what was configured, where did it break? Now, how do I roll that back to make sure that the network is still going to function? So we didn't have a way to create a network-wide API for all these devices that may not be API enabled.
Everybody read this slide. I'm telling you, this is why we do what we're doing right now. This is very important information. So whenever you guys start talking about why programmability, why we go, and this is even last week when we were talking about when I had that pexpect script on. You guys know now that's the problem that we're at least moving past with using APIs. So sorry, go ahead, Quinn.
You're fine. We're trying to move past. I mean, it's not to say that an API is the solution to everybody's problem, but it's something. So not all heroes wear capes, and the reason I say this is because NSO, I love it. In fact, I have NSO stickers on just about everything. I think I've got it on my phone too, buried behind the snail. That is really an incredibly powerful tool for enabling us to orchestrate that assurance, but also find us a way to that other way is distracting. Find a way to contextualize the network in a way that not only provides us the structured data from our configurations, but in a way that we consume them. It can consume that and drive other automations in the same platform. So I will make some analogies to other things as we get further on down. That's not to say that NSO does these things better than any other tool, but it's the entire package. It's that gestalt. The whole is greater than the sum of its parts kind of methodology that really makes NSO shine from other utilities. So using NSO, I can connect to any other device, and the things that I'm going to be talking about today are driven by SSH. We're still using those same standard protocols that we use as network engineers. It can consume things like netconf and restconf. It can consume things via API, but the problem that we're trying to solve is how do we APIize the network for things that don't natively have an API? If they support netconf and restconf, well, we can use things like NC client, or we can use restconf with REST APIs to provide that configuration or scrape some of that data out, get that structured data that we need. If they support an API, yeah, we can just query that API and it's going to give us back some structured data, whether in JSON or XML format, that we can use and kind of stitch together with some Python code or some Go code or something like that. This is the case of that brownfield environment. I've still got 6500s, heaven forbid. I love them. They're workhorses, but they're end of life. How do I APIize my 6500s? Well, you have to do it via SSH and something that's going to parse it. So we have this parser logic that's built into NSO, and you'll hear me use the term NED, Network Element Driver. That NED is a custom-built piece of code that takes the configuration that's supported on that device and runs that the configuration that receives through SSH against that device that or that configure that pulls back and parses it. So if you're familiar with something like PyATS, NSO does something similar to PyATS. The output logic is a little bit different, whereas PyATS is trying to get you into structured JSON, and they nest those things like crazy. JB and Simming do a great job of all that. This is something a little bit different. We're trying to parse it into something that's very netconf readable. So we're using XML output data. We can display that data through any number of ways, but we're trying to, again, take the unstructured data, peel it back, parse it out, and then present it in a way that's machine readable. So running this entire loop through there, we get this output. So that same IP address output that I showed in the previous slide, when we run it through NSO, gives us something like this. And this is known as XPath, which is a format for displaying nested XML. So if you can imagine this as being a big XML document, we're just including these paths. We don't have the nested tags. We're just putting on a single line. So now through each of these things, we can see where did this configuration come from. So if we look at we can just take this IP source route and IP routing. We can see that it's nesting through the tree of devices, device name. We can see it's from iOS 0, which we saw from that show output. We can see that's in the configuration parameter, so it's a configuration level item. And it's under it's an iOS device, which is where you get this iOS tag. It's a netconf namespace. And then it's under the IP branch and routing, or source route, true. So we've enabled IP source routing. So we can see where in the tree that piece of configuration data lies. More importantly, if we look through some of those interfaces that we were talking about earlier, where we had those IP addresses, we can see it's parsing through the interface fast Ethernet 01 IP address. It's a primary address. It's not a secondary, and we can see where that's coming from. So just by parsing this data out, we can see exactly where each line of configuration comes from in that device tree and output it in a way that we can now work with it from a programmatic aspect. So there's a lot to take in there, and this may look confusing at first. We'll dive into a little bit deeper in some of the hands-on demos that I've got going on. But this is really how NSO is going to go through and parse those configurations in a way that we can start interacting with them in a programmatic nature. And because I love memes, we have context. So through all of that, through all the work that goes under the hood with NSO, we have now taken those CLI unstructured configurations. We've made sure that through NSO's architecture, which we'll touch on in a few other slides. And through the parser logic, we have assurance and context for our programmatic operations that we'll be using through NSO. Any questions so far? I'll take silence as golden. So the other key piece of this, and you'll see a lot of references to Yang. I know I've already mentioned netconf and restconf, and I'll touch a little bit on that when we talk about the how NSO works under the covers. But before we can dive into understand exactly how we automate that or that assurance through NSO, we have to understand Yang. And you've heard about Yang. It's yet another next generation, I think, is how people have kind of explained the acronym away. Defined by a couple of RSCs, 6027 and 15. I think there's one in the 8000s that's relatively new in some of the new Yang namespaces. But Yang is a modeling language designed for network models. So that sounds abstract, but when you think about any programming that you've had to do, whether that's web development, whether that's even C or C++, or MIPS assembly way back in the day, if you did that in university, in order for us to figure out or make a program, we have to design. Usually your professors will say design a model, do pseudocode, do a block diagram. What's the finite state machine of this program going to be? It's only after you understand the flow logic for that program can you actually create it in code. Otherwise, it's like, oh yeah, I got to go back and fix this, or you add new, functions or whatever, and if something breaks because you haven't appropriately accounted for that in your overall model. In order for us to program the network, we have to have a similar model for how we can control each device. And Yang is kind of the standard that everybody settled on for how we do that. Other devices or other controllers may have different models. So, Derek, I know you're pretty passionate about ACI. It has the management information tree or management information model. Same kind of idea. We start with a top level object, and then we have branches that go down this tree and that end up in leaf nodes. And those leaf nodes are the individual configuration or operational level data that exists on that device. So if you think about going back to that configuration example that I showed with the parser logic, that individual IP address is a leaf that runs down that individual model all the way back to that iOS config data namespace. So Yang is very structured and strongly typed. So it's very syntactically, everything has to fit us individual types. There's a bunch of different types, but leaf list, leaf ref. You've got lists and a few other things in there. Each individual component of that model is typed, and the best way of thinking about it is like a doctor's intake form. So when I create this Yang model, I'm essentially setting the structure for how I want this data to be output. We know that when we go to a doctor, they're going to ask for some basic information, first name, last name, address, date of birth, height, weight, any allergies, any medical history, those kinds of things. That doctor's form creates a model, a structure for how data needs to be given back. So they know the receptionist or medical billing or whoever knows that when they look at this specific part of that form, they're going to find your first name. That will always be in that way. Same thing with Yang. If you're defining this segment of the device model and you're giving it a name with a specific type of data that can go in with a syntax checking, maybe we only accept IP addresses, we know that when we always look in this one spot, we're going to find an IP address. So that's a similar kind of analogy that I use to go back and forth. Every data model is a module, so it has a self-contained top-level hierarchy. Now, we can import data models from other Yang modules, so we can have a very nested, almost object-oriented programming type way for defining a model. So we don't need to have one single iOS model. We can reference different individual models that maybe talk about interfaces or talk about versioning or talks about routing. Those can be then imported into the main top-level model, so that when I import the top level, I get all of the children underneath it. The one thing I don't like about Yang, especially when talking about it in a devops concept, is it uses the term container, and that groups related nodes. And that's a little bit of a higher order construct, but you think of it as, and I'll plant the seeds and I'll talk about it a little bit later, but if we talk about or think about configuring something like an L3 VPN inside of a service provider environment. I know that's a lot of things to think about there, but there's some top level pieces that need to be associated with that, both on the CE side as well as the PE side. Well, I can make one Yang data model that encompasses both of those, but I can group the CE configuration, the customer edge configuration in one container, and I can group the provider edge, the PE configuration, in another container referenced in the same model. So it's a way I can separate those two things to provide them out. So I can group things how I want to, that makes the most logical sense to me in terms of the configuration. It uses lists to identify nodes that are stored in a sequence, just like what any other normal list in like Python or Java or whatever. And each individual attribute of a node is represented by a leaf. So when I talk about the IP address of that interface being a leaf node, that is a leaf at the very end of that whole model tree that comes back through the root of the iOS config data. And then every leaf must have an associated type. So is it an IP address? Is it a free form? Is it strings? Is it enumerate? And we'll get into that a little bit later.
I know this is a lot, guys. So if you have questions, please ask or wait to the end. But those concepts that he just mentioned, well, just Yang in general, it's very important you guys understand that. At least if you take something out of today, you understand the basis of Yang and why we need Yang. So,
yeah, and again, this is. Oh, go ahead.
So how does Yang square with YAML or JSON? Because I've been doing a little bit of Ansible. I'm trying just to see how it fit with this Yang model fit with YAML or JSON.
Yeah. And this slide actually may help a little bit with the understanding. So a Yang model is the definition. There's no native data in a Yang model. It's creating the structure for how we define the configuration of the device, but there's no configuration data in a Yang model. Yang is generally associated with things like netconf and restconf, which either send XML, if in the terms of netconf, or JSON encoded data in terms of restconf, towards a device, and it knows, based on how I've structured that data that I'm sending to the device, where that fits in the model. So if we look at this arbitrary sports ball model that I've created in Yang, and again, it's a terrible model, but it's because Yang is kind of meant for network models. It's not meant to define anything, but you can see that if I force the analogy, it kind of works. So if we think about a sports team, any sports ball team that's out there, whether that's football, basketball, baseball, you know that there's some things that what makes up that team. That specific team is a point in time. So I start off, I've defined the module as being called sports ball. It has a prefix and a namespace that I've assigned to that. That namespace becomes important when I talk about interrogating that device via RESTconf, via HTTP. Underneath that, I've defined a container called football team. That's something that I want to organize because I may be able to define different containers for different kinds of teams. I may have football for one and then basketball for another, or ice hockey, or maybe it's a speed skating relay team or something like that. So I can create containers based on how I want to organize these things based on what's important to me. So in this case, if I'm defining a football team, I know I'm going to group that in a single container. That football team now has a team name that I can reference. We all know of different football team names, and that's what identifies the team in general. And then it's going to be a string, an unformatted string. So it can be called anything. But we know that these teams exist throughout points in time. Just because Man U has a team and have been going on for decades or whatever, doesn't mean that every Man U team is the same. So I have to worry about what's underneath that specific football team. So now I'm going to call it each of the individual players that are on that team are a piece of data that I care about because those players are what make up that team. So I've given them a player name that's a string, the position they play, which is also a string, and their age at the time of playing, because those players may exist on a team for one or more years. So the age at which they're on that team becomes important. So now I have all of that data of all the team itself and the players of that team that represent that single snapshot in time for that team in the current moment. You see that there's no data there. I haven't defined any players, but it has given me the model that I can create and define the team as a whole and the individual players. Excuse me. So now that this model has been created, I need to fill that data
Sorry,
up.
Mr. Quinn. I'm sorry.
Yeah.
I couldn't write fast enough. When you said the model, you said you know, no, there's nothing defined here, but you said this gives you a model to I'm sorry, after that you said create.
Yeah, it's a model to create the team itself. So
Okay.
there's no configuration data on that left-hand side. But
Mhm.
we know that if we send data that aligns with that model, we can define that specific team at that specific point in time. Does that
Okay.
make sense?
Yeah, it does. Thank you.
Okay, yeah, perfect. So we have this model structure, but now we need to send data towards it. And generally, when we think about Yang, you'll hear netconf Yang. And that means that I'm using the netconf protocol over SSH to send XML payloads of data towards that model. So I know I don't have anything filled in here. However, we can see that we have this football team definition, and we have this team name with a space and a slash. That's just an empty tag in XML. I could do team name, end bracket, name of the team, and then slash team name, and that would be the data that I would send to it. And we'll see more XML data here in a second. Underneath there, I'll have players, and each player will have a player, and then I'll put in the player name here, and then end it, and then positions and ages, and then. So we have this data that we get filled out that we then send towards the device. It knows because this XML structure completely mimics the Yang structure. And because I've defined the namespace here as being the sports ball reference, this XMLNS's XML namespace, it knows to send the payload of data that follows this namespace. I'm sorry, send the data that follows to the specific namespace referenced in the data that is being sent and apply it towards the model that we've created in Yang. So again, it's just like that doctor's form. There may be one or more forms that you have to fill out. Maybe one is just your basic information. Maybe the second form is your insurance information. Your third is your medical history and allergies and things like that. You know that you're not going to put your allergy information on the first page because that's not what's called for. So this namespace reference is essentially saying, go to this page, or go to this specific model, and fill in the data with what I'm sending after it to align directly to how I've defined this sports team. So this is a very heady concept. So if you don't get on the first try, it's completely okay. There's a lot of people, even in network automation, that don't fully understand Yang, and I will claim to be a Luddite as well. I've just kind of brute forced it enough to figure it out. It's a very deep thing to get into, but the reason I bring up Yang is what backs NSO from a configuration standpoint, but it also allows us to work with individual models. You'll hear Yang models being referenced on individual devices, new Catalyst switches, new Nexus switches. They all have Yang models. Well, they have models that define the configuration that exists on that device, so you can configure them. It doesn't matter if I'm running Catalyst or NXOS. I figure the model, I build the data payloads and send it, and it will configure it. So
Quinn, that's actually the best definition I've ever heard of XLMNS. I was wondering so many times what it was for, and I got it. It was some kind of address, but that's the first time I really get it.
Okay, guys. So just so you guys know, we have a celebrity on this bridge. Iwan is actually a genius in Greece. So do you want to introduce yourself? Because I didn't think you were going to comment, but now that you comment, please introduce yourself.
Sorry, guys. I was late to the party. I had to pick up my daughter because it's Saturday evening here, so she was out, and I was a little bit late to the party, so I didn't want to say anything. So I'm not really a celebrity. I'm just trying to learn like everyone else. We do have a small community here that I sort of created with a team of people about automation, but that's about it. You can check things out on Twitter, like everyone else, like Quinn does or Derek does. Everyone here is a bit more active than I am, but I'm here to learn as well as you are. I'd like to say just that this is one of the heaviest concepts that I had to tackle with, and I can't say I mastered it yet. So this was really very helpful. The XMLNS, XML namespace, part on the right. It's the best explanation I've ever heard. I will tell you where this applies to. Thanks, Quinn. That was great.
No
Appreciate it.
problem. Like I said, this is a very heavy concept, and we'll see more of it when we start building services. But don't, like I said, don't beat yourself up. This is it. It's not. There's a reason that most people look at JSON data and they say this is much easier than XML, but there's so much value that is contained in XML that eventually you're going to have to learn it. But as you start playing around with Yang models, and even you don't even have to have NSO to play with Yang. As you start playing around with Yang models in XML and using NC Client, there's a ton of labs that are available on DevNet. Playing with NSO, understanding how things are formed, and you'll see more of this in my demos. It starts to click a little bit. And you go, oh, this isn't as intimidating as it was on the surface, or as I thought it was going to be.
And for those of you who are going for DevNet Associate, one of the blueprint items is knowing the difference between JSON and XML. Don't take that lightly because it can really get complex. But again, just to reinforce what's being said, please take time to understand JSON and XML and even YAML. Understanding the way those data, the way the data is structured and everything else. Just getting used to having your eyes look at it will make all the most difference, especially if you're going to get certified.
Yeah. The one piece, and this was stolen from another presentation I did about 2 years ago, where I did a little bit more hands-on with the actual Yang and XML data, is there's a program called PyYang that you can install from PyPy. PyYang allows you to take, you can either interrogate existing Yang models and you can move to their XML equivalent, or you can convert to Yin or to JSON or XML or tree or whatever other formats you want. It's a really powerful tool. I didn't want to spend a lot of time on it here because it does get pretty heavy. But if you do a lot with netconf and Yang models, there's a lot of work that's being done. I know John McGovern does a lot of stuff with, I think he's with CBT Nuggets. You'll see him on Twitter as IPv0. He does a lot of work with an automation using netconf and Yang models, and he dives really deep into using Linux utilities like PyYang to figure out how and where to send that information to the right namespace or the right tree of that individual model. So there's a lot of information that's out there, and once you get really good with PyYang or NSO, you can use NSO to do roughly the same thing. Again, it all just kind of makes a lot of sense. So that's another utility you should probably keep in the back of your mind. For DevNet Associate, all of this stuff is very much beyond DevNet Associate, but if you understand these things, you will be completely ready for the Yang and NSO pieces of DevNet Associate. So